We're continuing on the AP Chemistry Chapter 5 notes, and now we're going to look at one condition problems. One condition problems, there's only one way to do it. You have to use specific units that are given in the formula, which are ATMs, liters, moles, and Kelvin for temperature. R is a constant. It's always going to be 0.0821, and the units are liter atmospheres over mole Kelvin. So you have to use these units for one condition problem, which I'm going to say PIVNERT to refer to this equation. So in the past notes, the two condition, you were allowed to match the units. So if we go back here really quickly, as long as you match the units, you're okay. Except we said, of course, you have to use Kelvin no matter what. Okay, so any units on both sides that are the same are okay, except you have to use Kelvin. But in this page, you must use the units given. So you can remember two condition, there's many ways to do it. One condition is only one way to do it. Only one way with the units. So whenever you have a one condition, you're just going to use PIVNERT, PV equals nRT. And we're going to look for each part of this. So we look for the pressure is what we need. So the pressure is the unknown here. And you know that this is going to be in ATMs because it has to be in ATMs for this type of problem. Okay, the volume was 20 liters, so you're just going to write 20 liters right here. The moles was given as 5 moles, so we're just going to write 5 moles right here. R is always 0.0821. The units are liters, atmospheres over moles, Kelvin. And the temperature is given as 30 degrees Celsius. Of course, you know you have to change that to Kelvin, so it's going to be 303 Kelvin. So no matter what, you got to use Kelvin for all of this chapter. Okay, now throwing this into the calculator, 5 times 0.0821 times 303 divided by 20 gives you 6.2 once we rounded it. So 6.2 ATMs is going to be the pressure in this container of this gas. Now let's suppose we're going to move down here to solve the next one. It's the same type of problem, PV equals nRT. And we're going to look at what they gave us in the problem. We're trying to find the volume now. So if we don't know the volume, it's over here. But we do know it's going to be in liters. The pressure was given as 54.0 kilopascals. Now you can't use that, you have to use ATMs. So you have to do a little conversion, 54.0 kPas. There are 101.3 kPas in 1 ATM. So when you do the math for that, 54 divided by 101.3 gives you 0.533 ATMs. So that's going to be your pressure in ATMs. So you're going to write 0.533 ATMs. Okay, next we're going to look for the moles. Of course, that's in the wrong unit as well, 16 grams. So you have to take 16 grams of oxygen, convert that into moles. Now you could do that in your head because you know it weighs 32, but we'll just show the work. 32.0 grams per mole. So that's 0.500 moles. So that's going to be 0.500 moles of oxygen. Next, you're going to throw R in there, which is always this number, 0.0821 liter atmospheres per mole Kelvin. And lastly, the temperature was given to you as well. By the way, let me circle this so you know where I got that. Got this from pressure. Temperature is going to be 40 degrees Celsius. Again, you can't use that. So you're going to have a 313 Kelvin because you add 273 to get Kelvin. And now you're just going to do the math for this. 0.5 times 0.0821 times 313 divided by 0.533 gives you 24.1 liters. 24.1 liters. So 3 sig figs is good. 24.1 liters. That's the volume. Okay, lastly, One condition problems also can be in this format. Molar mass equals density times R times T over P, or I might refer to this as dirt over P. So molar mass equals dirt over P, and we said the top equation could be referred to as Pivnert. So now what we're going to do is look for the missing piece here. We're trying to find the density, so that's going to be the D. That's always going to be in grams per liter. R is still always 0.0821 liter atmospheres per mole Kelvin. We're going to look for the temperature, 12 degrees Celsius plus 273 is 285 Kelvin. The pressure is given in the wrong units as well, because you have to put the pressure into ATMs. So you could go down here and you know that every 760 millimeters of mercury is 1 ATM. So when you do the math for that, you're going to get 1.05 ATMs. So that goes over here. Now you need to know the molar mass of fluorine. So you get that from the periodic table. 2 times 19 is 38.0 grams per mole. That was from the periodic table. And now you're going to do your math. So 38 times 1.05 divided by 0.0821 divided by 285 is going to give you a density of 1.7. Now remember, this is grams per liter. Don't get this confused with the density of water, because you know the density of water is 1, right? Liquid. But that's 1.0 grams per milliliter. This is the density of a gas, which is 1.7 grams per liter. So clearly, a liquid is more dense than a gas. So don't get that confused. And these are one condition problems.